Hello everyone, in this video I am going to look at the concept of free fall. It is a special case of accelerated motion where both direction and magnitude are constant, and there can be different interesting cases of special cases of acceleration. For example, horizontal component of a projectile motion, the magnitude is 0. Free fall, which we are going to see now, where both magnitude and direction are constant. Uniform circular motion, where the magnitude is constant but direction changes, and simple harmonic motion, where both magnitude and direction changes as a function of time. Before going ahead, it is worth looking at some sign conventions. For position, the ground level will be taken as 0, upwards will be taken as positive direction, so the acceleration would be minus 9.8 meter per second square, as it is pointing down always. For an object moving up, the velocity is positive. Since acceleration is negative, the velocity decreases as a function of time until it comes to 0. And when the object is moving down, velocity is negative. Since acceleration is negative, the velocity magnitude increases as a function of time. Now let's put object at ground level and throw it up with a velocity of 50 meter per second. So it is at ground level. In this simulation, this is the ground level and this is upwards. First, let us see what happens if it is thrown. So generally this is what we see. You throw an object up, it will go up and come down. Let's see it again. So it would take 10.2 seconds and reaches a height of 127.5 meters. Now let us look at the object at equal intervals of time and also concentrate only on the upward motion. I'll put a guideline so that it becomes easier to observe, and at intervals of 0.25 seconds the position of the object will be marked. So let us see. This is how the object goes. So as we can see, with successive intervals of time, the distance traveled or the height gained becomes smaller and smaller until it reaches the topmost position, where it changes its direction and comes down. Let us see it much more slower motion. For that, I have put an object at ground level, and I will also throw it up with a 50 meter per second, but this time I will use a time slider to observe the position. So this is at ground level. So this is at ground level. This is at ground level. This is after time of 0.25 seconds, 0.5 seconds, 0.75. Now progressively we can see the distance between two successive time intervals is decreasing. Now similarly, when the object is taken to a height and left from that height with 0 speed, a similar phenomena happens. Let us see that. Let us put the object at 127.5 meters at the same height and leave it with 0 meter per second. So this is what would happen. Now let us compare it. So the object is at 127.5 meter and it will just left released with a speed of 0 meter per second. That is, it is neither pushed or pulled. So now let us look at it. This is at equal to 0, 0.25 seconds, 0.5 seconds, 0.75. So initially it moved a very small distance. Now we can see a small separation, and the separation increases as a function of time. As a function of time, the distance traveled increases. There is another interesting case where the object is taken to a height and thrown up. let's say it is at 30 meters and it is thrown upwards. Let us observe that motion. So it goes up and then you can see the color changes. Let us observe. It goes up and in the reverse we can see the guideline colors changes, indicating the change in the speed. Now let us compare the motions by changing the initial speed. Now both the objects are placed at 0 position. The red object will be thrown with 50 meter per second and the blue object will be thrown with 40 meter per second. Let us see what happens. So if the initial speed is high, the height gained would be more and the time it takes to go up and come down is also more. Let us see this, make it 30. Now both are at ground level. Let us observe. The second one has reached its maximum height and it has come down, while the red one goes up and comes down. Now we can also look at the position time graph and the velocity time graph for the motion. At t equal to 0, it is at the ground level, and let's look at it. T equal to 0, it is here. Time is on the x-axis and height as measured from ground is on the y-axis. So here it's reached the maximum height. Now it will come down. Now let's look at another speed. Let's say 60 meter per second and draw the position time graph. Now since the speed is more compared to the earlier case, it would go more height, that it is going more than 130 meters, which was in the last case. So it has reached almost up to 185 meters. Now let us look at velocity time graph. Now on the x-axis it will be time and on the y-axis it will be velocity. Now this is a constant acceleration, remember, so the graph will be a straight line. So let us trace that. So at t equal to 0, it is 50 meter per second. As the object is going up, the velocity is positive. It is 30 meter per second now at 2.2 seconds. So this is almost, it has reached the topmost position where velocity is 0. Now the color has changed, indicating that it is coming down. Since it is coming down, the velocity is negative. Let's look at another case, 60 meter per second. So initially at t equal to 0, it is 60. So as you can see, the change in velocity is same for a equal interval of time of 0.25 seconds because the acceleration is constant. Now here it has crossed over, the velocity has become negative from being positive. So the simulation ends here. Thank you for watching this video.